This is Sukriti Joshi. Our today's topic for this video session is the reactions which are nitration and amination. So we'll take a look here on two different types of reactions. Number one, nitration. Number two, amination. Generally, these all are different types of organic unit processes. So organic unit processes are basically, or they can be defined as the major chemical transformations which are very important to various chemical industries such as dye, pharmaceutical industry, polymer industry, insecticidal industry, as well as in explosive industry also. So they are the processes which are done in batch. Okay, so they are done in bulk. So basically this type of different chemical transformations involves different types of reactions or different types of processes so that we get the desired result. Okay. We will first begin with the reaction which is known as nitration reaction. So nitration is an example of electrophilic aromatic substitution, and the nitronium ion, which is basically NO2 plus and sulfur dioxide SO3, are the electrophiles, and they individually react with benzene to give nitrobenzene. Right? So this shows that how nitrobenzene formation actually occurs. So in general, nitrobenzene formation occurs through the reaction which is concentrated HNO3 plus concentrated H2SO4, and along with both of them in the presence of concentrated H2SO4, it reacts with benzene, and that nitro group will be transferred to it. So we will get a nitro group containing compound using this particular mechanism. So nitration is the process with which nitro group is introduced in the molecule. Various nitrating agents are there, and they are as follows. First one is concentrated HNO3. Second one is concentrated HNO3 plus concentrated H2SO4. Then we will have concentrated HNO3 plus CH3COOH. Last but not the least, concentrated HNO3 plus CCl3. So in general, these are known as nitrating agents which are most widely used for the nitration process. Right? They all gives rise to the nitro group. The nitro group will be attached to that particular. But from all of these nitrating agents, most common reagents used here for nitration is concentrated HNO3 and concentrated H2SO4. So generally, concentrated HNO3 plus concentrated H2SO4 combination is most widely used combination for nitration purpose. Okay, now let's talk about the mechanism of nitration. So the first step in the nitration of benzene is to activate the HNO3 with sulfuric acid to produce a stronger electrophile. It basically gives rise to the nitronium ion. What will happen here? HNO3 will be activated to nitronium ion using concentrated H2SO4. That H2SO4 will directly, it will not take part in reaction, but it will activate the concentrated HNO3. So as you can see it in the image here, what we will get is basically HNO3. It's been shown in different way. So OH attaches with N plus, so N contains positively charged, O contains negatively charged. One oxygen is bonded with nitrogen with a single bond, another one will attach with the nitrogen with double bond. So here it will react with, or it will combine with H2SO4. As you can see here, H-O, SO3H. So now what will happen here? That particular group, that L, the H will attach to your OH. So that will create one more compound which is known as N plus O minus, double bonded with oxygen and single bonded with OH plus, and that is OH plus and one more H is there. So that whole combination is there, as you can see, and HSO4 minus is produced. Now what will happen? Here that particular group, that compound will again further be completed or be converted into NO2 plus. So N double bonded with oxygen, double bonded with oxygen plus H2O. So in this manner what will happen? You will get H2O. So that H2O will be removed from one part and NO2 plus remains on the another part. So HNO3 is converted into an activated form, which is known as NO2 plus, but using what? Using concentrated H2SO4. Right? So in this manner you can understand that how it goes and how actually it converts itself, or it will be there into its own activated form. Right? Now let's see that how nitration of benzene occurs. Now in this particular one, what will happen? This NO2 plus will then further react to the substrate and nitration process will be complete. So in this manner what will happen? You have your substrate, the attack will be done by our NO2 plus, it will attach with it and it will convert itself into a nitrated product. Okay. Now let's see that how nitration of benzene is done generally. So benzene reacts with concentrated HNO3 plus concentrated H2SO4 and convert itself into nitrobenzene. As I said you, in the first one, HNO3 will be converted to NO2 plus and H2O will be removed from it, and that NO2 plus will attack on our benzene's particular position and attaches with that benzene and creates nitrobenzene. Okay. So this is basically an application of nitration. Right? Let's see the second application of nitration, which is preparation of TNT. So its full form of TNT here is trinitrotoluene. So 2,4,6 trinitrotoluene. How it will be done? So generally toluene will be react with fuming concentrated HNO3 or fuming HNO3, highly concentrated HNO3. Okay, so 3 parts of HNO3 is taken and then we will have our toluene along with it in the presence of concentrated H2SO4. It will give rise to 2,4,6 trinitrotoluene plus 3 parts of H2O is removed. Okay. So TNT is most widely used as an explosive in different industries, in mining industry, in explosive industry, in cracker industry, etc. And it plays a very important role. So we have to see that how it goes. So in industry, TNT is produced in a 3-step process. First, toluene is nitrated with a mixture of sulfuric acid and nitric acid to produce mononitrotoluene, which is known as MNT. First of all, MNT is produced. This particular MNT is separated and then renitrated to dinitrotoluene or DNT. So first of all, what we will get here is MNT, then we get DNT. In the final step, the DNT is nitrated to trinitrotoluene, which is known as TNT. So MNT to DNT to TNT using an anhydrous mixture of nitric acid and oil. Okay, so in this manner we get our TNT done. TNT is one of the most commonly used explosive for military purpose, for industrial purpose, and for mining applications. Let's see another example, another application, which is nitroglycerin. So nitroglycerin is prepared by running highly concentrated, almost anhydrous and nearly chemically pure glycerin, which is known as dynamite glycerin, into a highly concentrated mixture of nitric and sulfuric acid with constantly efficient cooling and stirring, in combination with nitrocellulose and stabilizers. It is the principal component of powders, gun propellants and smokeless solid rocket propellants. Now, as you can see in the image here, glycerol. Okay, so what we have is glycerol will be reacted with 3 parts of concentrated HNO3 and 3 parts of H2O is removed, while NO2 is attached to all the 3 carbons, become glycerol trinitrate, which is known as nitroglycerin. Ng is considered as a very good high explosive. Okay. Let's talk about amination. So amination is the process in which amino group is introduced in the compound, and that's why it is known as amination. It can be done by 2 ways: amination by reduction and amination by aminolysis. Let's see the first one, which is amination by reduction. So when nitro compounds are reduced, they give amino compounds. The reducing agents which are used are zinc ion in presence of HCl, catalytic reduction with platinum and Na2S. Next will be amination by aminolysis. So here, as you can see in the image, what we'll do is M-dinitrobenzene is there. Amination, that is partial amination, will be done, and that is reduction process in presence or with NH4 twice S. So we get M-nitroaniline there, reduction will be done. Again further if we reduce it, so amination reduction again done in the presence of SN and HCl. So at that time what will happen, it will convert itself into M-phenyl-diamine. So 2 groups of NO2 will be converted to 2 groups of NH2. In this manner we will get our reducted or reduced product. Okay. Another example is formalin. So as you can see in the image, formalin reacts with 4NH3, aminolysis, amination, convert itself into HMTA plus 6H2. Okay, so in this manner, it's possible that using such kind of reduction processes, we can convert nitro group into amino group. This is all for this session. Thank you so much, everyone.